Salam alaikum everyone. Good evening and welcome to the fourth and last talk of Devfest25. We're delighted to have you join us for an exciting and insightful talk on a topic that lies at the very heart of modern software development, DevSecOps, how security is integrated into the development lifecycle. In an age where cyber threats are constantly evolving, ensuring security at every stage of development have become more crucial than ever. And today we have the perfect expert to guide us through this subject. Our speaker today is Mr. Abdelhamid Benhami, a cybersecurity analyst, software developer, and PhD in e-payment security. During this session, Abdelhamid will walk us through how security principles can be seamlessly integrated into the DevOps process. So, without further ado, the stage is yours, our dear speaker.
Okay, thank you, my guy, for this introduction. And hello, GDG Algiers. It's Abdelhamid Benhami. Today, I will introduce you to the DevSecOps approach, or how security is integrated to the development lifecycle. Okay, first of all, we have to know what is a development lifecycle, or SDLC. The development lifecycle, or SDLC, is the process of creating and maintaining software through key phases: planning, design, implementation, testing, deployment, and maintenance. It ensures that projects are well organized, efficient, and produce high quality, reliable software that meets user needs. Okay. Now, how security can be integrated to each part of this development lifecycle. Integrating security in the development lifecycle means making security a continuous and intentional part of the entire software development process, rather than something added at the end. Unfortunately, in Algeria, security is majorly added at the end of project where I worked before, when we deploy isolation or integrate isolation, the development team always come for us at the final stage. And that's not much the DevSecOps approach. If you can see in Europe or North America or even the ASEAN approach of development, security is always integrated in the lifecycle of the development. It can be in the first part, in the second part, or even in the last part. Okay, it involves planning for and addressing potential security risks at every stage. This is what I cite, from the initial idea and design to coding, testing, deployment, and maintenance. Now we're gonna see how can security be integrated to each part. Okay, just a quick reminder about the fundamentals of cybersecurity. Cybersecurity fundamentals are the CA38, which means confidentiality. Every information that is confidential should remain confidential. Availability, our system must be available when we need it and must be available for the person who have the right to access. Integrity, our system or our software must ensure the integrity, which means that no one can change something in our data, for example. Okay. In the planning and design stage, we can integrate security by employing risk management or even making an audit about the language and frameworks that we should use. Okay, we can, before even starting development, audit our softwares, see, for example, if the version of WordPress that we're gonna use is not vulnerable, if this version of, for example, PHP doesn't contain a public exploit or explosive vulnerabilities. Okay, we can also make what we call an SDLC policy. We can, as a security team, make our exigence and write them in a policy, in a document that we transfer to the development team or even the deployment or system team, where they can see our exigence and requirements before every deployment. Okay, this is what we can apply at the first stage of development, which is the planning and designing phase or part. Okay, in development stage, we're gonna also have at the end of this presentation, as I imagine the most members of this club, sorry, are majority developers. We're gonna have two workshops how we can use SAST and dust scans to scan source code statically, and how we can apply dust scan to scan application for in order to identify vulnerabilities. So in the development stage, we're gonna have the SAST, which means security application static testing, and we're gonna also have the dynamic application security testing scans. Okay, we're gonna see this part at the last of this presentation. In the testing stage, we can have the pen testing. Pen testing, what pen testing means that we're gonna play the hacker roles in order to identify the vulnerabilities in our system. Okay, so we're gonna switch to a hacker just to identify potential vulnerabilities or backdoors out our system. We can also apply a stress test. What means a stress test? A stress test means how can our application handle if we have multiple access simultaneously. Okay, how can our application handle, for example, 5,000 users? Okay, this is at the testing stage. And finally, the deployment stage. What we're gonna have in this part, we're gonna have a vulnerability scan of the asset. Of course, after development stage, after the testing stage, we have to deploy the code or the application in a virtual machine. Okay, the virtual machine itself must be audited or checked for potential vulnerabilities. Okay, so we're gonna apply a vulnerability scanning for the virtual machine or the asset. Okay, we're gonna have the firewalling and WAF part. What means firewalling? For example, if my application gonna be published in the internet and should be accessed from outside, we're gonna put it in a DMZ zone. Okay, and we all know that DMZ zone doesn't need a traffic with the production LAN, for example. So we can apply a rule in the firewall that deny every traffic from the DMZ of the server that we deployed to our board, for example. Okay, we can also apply a web application firewall. What means a web application firewall or a WAF? Simply, it's an applicative firewall that can block some well-known attacks like SQL injections, like XCSS injections, like multiple attacks. Okay, we have also the last part is the CM and EDR integration. Okay, CM, what means CM? CM means that our product or our software gonna generate some logs. Okay, we can make in the development we can make our solution in order to generate some logs. Okay, for example, if my application is published in internet and I have the main page which is index.html, I can make some logs that change every that log every change on this page. Okay, so that tomorrow if there is something that is changed in the index.html page, I can verify. I gonna receive alert in my CM and I can verify with the development team if it's an attack by an attacker that changes the index.html of our site, or it's just a developer who edited it. Okay, the IDEA integration means that we're gonna deploy an antivirus in our asset. Okay, the antivirus can also block some well-known virus using their signatures. Okay, so this is a short graph that resume all what I said before. We have four principal parts, which are design, development, testing, and deployment. In the design part, we can have risk analysis, as I said, frameworks and language audit. In the development part, we're gonna have the dust scans and the SAS scans, and that is the important part for every developer. So every developer should know what a dust scan means and what a SAS scan means. Okay, because that's two last parts, they are not potentially the role of a developer to ensure them. I speak about the testing and deployment part. It's more the system of network administrator and the security engineers. Okay, so you as a developers, you have to know these parts, DAS scans and SAS scans. Okay, and this is why I chose these two topics as workshops of our presentation. Okay. As I said, during the first stage of the SDLC, conducting a risk analysis and language framework audit is essential for ensuring software security. Risk analysis identifies potential security threats, vulnerabilities, and weaknesses that could compromise the systems, allowing teams to develop strategies to mitigate them early. We can, for example, we can use EBIOS RM as a risk management framework, for example. Okay. Meanwhile, a language and framework audit evaluates the security and reliability of the technologies being used, ensuring they are up to date, well supported, and free from known vulnerabilities. We can use this website in order to check if a certain version of the language that we're gonna use is, for example, vulnerable. Okay, so you just put in Google this site. Okay, serve details, CPU details. You access the first result that appears. Okay, here you can go just at the left of the screen and you can see version search. Okay, you just click on it. Okay, here you can put that your vendor name is, for example, PHP. I'm gonna put, for example, PHP 7.4. Okay. For example, the PHP 7.4.33 contains an overflow vulnerabilities. So we have to know at the first part of our development that we can't use this version of PHP because it contains a critical vulnerability. Okay, so just remember about this website or pin it in your notebook. The SAST and dust scans. The dust and SAST scans can be ensured by either open source solutions as SonarCube that we're gonna see today, or OWASP that we're gonna see today. But the most, how we say efficacious in English, I forget that. But the most useful tools are unfortunately not free. Okay, so SonarCube is a good solution for for students and for learning purpose. But in the professional environment, we have to pay the enterprise version of SonarCube. Okay, same as OWASP-ZAP. OWASP-ZAP is an open source dust scanner that scan the website dynamically, but contains multiples false positives. Okay, that's the point about the dust and SAS scans. We're gonna see them at the end of this presentation, inshallah. So during the testing stage of the STLC, security and reliability are reinforced through penetration testing and stress testing. Penetration testing simulates real-world cyber attacks to identify and exploit vulnerabilities that could be used by malicious actors, allowing developers to fix weaknesses before release. For penetration testing, you can use multiple tools from the reconnaissance stage or even exploitation and post-exploitation. For example, I cite that we can exploit some vulnerable versions about frameworks or languages, but how can I know if this website contains this version of PHP? Okay, you can use this navigator extension, which is called Wapalizer, that will list every language that is present in your website. For this example, I can know that severe details contain PHP, contain jQuery 3.7.1. Okay, so the pen tester what can do, he have just to search on Google about jQuery 3.7.1 vulnerabilities. Okay, and here he can see if there is some vulnerabilities that are present about this version for a potential exploit. Okay, voila, that's for the Wapalizer extension. Also, you can use the Burp Suite solution to change the HTTP or even to proxy the HTTP request. Okay, like if I have an admin panel and the admin panel contains redirection to the login page, I can use Burp Suite to cancel the forced redirection to login page in order to access to the admin page. Okay, so the Burp Suite is a massive toolkit for multiple web penetration testings approaches. Okay, so as I said before, as a developer, you are not very interested about that, but you are more familiar with the dust and SAS scans. Okay, also we have the stress testing that can be simply done just using a Python library which is called Locust. Okay, I can deploy Locust in my personal computer and simulate that there is like 5,000 users in my website, just to see how my website can handle that. Okay, and the last part, I know that the most of you are students. Sorry, the most of you are students, so I tried to pick only open source solutions. Okay, so here we spoke already about Burp Suite. Burp Suite is a free and open source. We spoke about Wapalizer, that is free. We're gonna see OWASP, ZAP, and SonarCube community editions that are also free, and Locust also is free. Okay, in the last stage of our secure development lifecycle or software development lifecycle, security is strengthened by implementing multiple protections. As I said before, we can apply an asset vulnerability scans using a tool called Tenable Nesis. Okay, if I run a scan with Tenable Nesis in a virtual machine, it will show me all present vulnerabilities in this asset. Firewalls and web application firewalls. We can use pfSense free firewall, and we can deploy it in a Linux virtual machine, and it will act like a real firewall. Okay, so I can block traffic from an asset to a LAN or to a WAN just using a pfSense firewall. Also, we can use a mod security, or we can use mod security that is a free web application firewall. Okay, the web application firewall protects our system or our softwares from well-known attacks like SQL injections, like extended SQL injections, XCSS injections. Okay. CM and ODR, there is not a lot of free and open source CMs, so you can check about, or you can search about the ELKA CM and how can we create use cases to ensure the security of our application. And for ODR, you can download and see how can open ODR ensure the security of your VM that contain the source code or the software that you developed. Okay. Here, all tools are community edition or free. Okay. Thank you, and let's go to the workshops time. So the workshop one is what? We're gonna make a SAST analysis or a code review with SonarQube. Okay. So SonarQube, as I said, is a free tool that you can just download it from Google. So you put SonarQube and you go to the first results. Sorry. Here you can click on the download. As I said, there is a lot of variants. So for us, we're gonna pick the community build. Okay. The developer edition and enterprise edition or data center editions are not for free. The difference between the versions are the number of languages that they support and also the number of rules that they support. Okay, here you can just download it. You have to have Java before and PostgreSQL before. So you need to download Java before and PostgreSQL before. Once you download it, you just go to the folder or its folder, which is here. You open the bin subfolder and then the Windows subfolder, and here you can open the CLI. Okay, you just have to put these commands to start the server. How is it? Okay, it isn't started. I think because I already have this is because I have already opened the SonarQube instance, so I just gonna close this and this, and we try to start it. Okay. We check if the server started. Okay, as you see, now the server of SonarQube has started. We can access to our home dashboard using our account. Okay. Once logged on, you can have this project or this dashboard. Okay. Here you can import your project locally. Okay. Or you can even import it using GitHub or Azure DevOps. Okay. So if you have to follow the DevSecOps approach, you can also create a pipeline in your development pipelines that gonna make that gonna launch at every or at each commit of your project or each push of your project. It gonna launch a scan in SonarQube. Okay. Currently, I don't have a personal project that I use with GitHub or as if DevOps. That's why I'm gonna create a project locally. So I downloaded a PHP project in the web, which is online voting system. Okay, this is my source code. Okay, it's an online voting system. Before I launch a scan, I can show you some rules of how these solutions work. So this solution use rules in each languages. These rules can detect vulnerabilities or misconfigurations in our source code. For example, the community edition of SonarQube have 695 rule about Java. Okay, so for example, here important should not be used on keyframe. This is a problem of variability. Okay, uh, the difference between SonarQube Community Edition or the the Enterprise Edition, for example, is here the number of rules. For example, if you see the Enterprise Edition, you can have like 2,000 rule in Java and 1,000 rule in TypeScript. Okay, and you can also have other languages than this. Okay, the supported languages in this Community Edition are this. Okay, I repeat, this solution supports both local offline scannings, okay, or even the DevSecOps scans. So I can create a pipeline in my Azure DevOps that gonna launch at each commit or each push in our source code, gonna launch a SAS scan, okay? But to simplify that, we're gonna see an offline scan, okay? So I'm gonna create a local project. I'm gonna name it, for example, tests GDG. Okay, I created a project and now I name it as GDG test. Okay, I'm gonna just use the default instances or default configurations. Okay, that's not very important. The platform repeat me again if I have to scan my code using a DevOps solution like GitHub or Azure DevOps, or just locally. Okay, me, I'm gonna scan it locally, as I said before. I'm gonna generate a token. Okay, here is it. And here I have to specify the languages that my source code contains. Okay, principally my source code is PHP source code. Okay, we can see here that mostly the most number of the most pages are on PHP. So I can just scan with the PHP scanner. Why the solution tell me to identify the language that I use? Simply because that the solution have multiple scanners, and for each language it's gonna use the appropriate scanner. For example, for the PHP scanner, for example, for the PHP scanner, it's gonna use this scanner. Okay, but for .NET, I have to download the .NET global scanner. Okay, so each language have his own scanner. That's why the solution tell us to pick our language. Okay. Once I picked the language and chosen my OS, I can simply copy this CLI line. Okay. I just have to copy it. Okay. Now, after copying the command, I open my main source code or my main branch, and here I open another CLI. Okay, I just pass the CLI line that I copied before and press enter. Okay, now what the platform is making, the platform of SonarCube is scanning our source code. Okay, we just write how the platform scan our source code and we see the results in the platform. Any question about the SAS scan, or is that clear? If I can check if I have some comments. Okay, there is nothing. Okay, the scan still processing, so we just write that. It can depends. The time can depends on the number of on the size of your source code. If you have a big source code, the scan can last for like 1 hour or 2 hours. But if you have just a short source code like me, it don't take a lot to process the results. And I repeat, here we applied the not DevSecOps approach because we didn't scan the code in the initial or the development stage, but we scan it in the final stage. Okay, the idea is to apply this scan in each modification on the source code. Okay, to respect the SecDevOps approach. Okay. As you see, the scan have been completed. So we just have to wait that the results will appear in this page. I just have to keep this navigator open in order to see the result. Okay, now we have just to wait like 1 or 2 minutes so that the result can be printed here. Okay, I just refresh the page. Wait something. Here is it, the result of our scan. Okay, we can click on it to see the result in details. We can see that we have 6 problems or 6 issues about security and 116 issues about security hotspots. What's the difference between security and security hotspots? Security hotspots are more critical or severe infringe than security. Okay, we can also, the SAS scan will not only show the security results but will also show some results that can help the developer for a better or a cleaner code, like the duplication percent. Okay, so here in my code I have my code that contain 5.8% of duplication, so that it's not a very well good for a clean code. We can also have about some indications about reliability. Reliability is what means reliabilities. Reliability means that we have a problem in our code, but the problem is not in doesn't touch the security context or purpose. Like I will give an example. If I have an if and else condition, but my else condition contain nothing. Okay, so it's like this. If it's like this. Okay, I have here if and there are some extensions, and here I get else, but there is nothing in my else, which make the if else statement useless here. That's a frequent reliability problem. Okay, it's not relative to security, but it's a problem in a clean code. Okay, also we can have some maintainability problem, like if I have a long program that is used multiple times, I can just put it in a function and I will call it when needed. Okay, so me as a security analyst, I'm gonna show you some security issues. Okay, if I open the security issues, I can see here that I have a line of code that contain a database that is not protected by a password. If I con if I open it, if I open the page of this, I can see that I have a MySQL instance with the default root usernames, but that doesn't contain a password. Okay, so I have to protect or to change this code. The platform can help us to identify where is the issue and why is this unusual. Here, if we see what is the impact of this vulnerability, once connected, an attacker can perform various malicious actions, such as viewing, modifying, or deleting sensitive information, potentially leading to data breaches. Okay, so it tells us why is this a problem or a issue for our code, and also how we can fix it. For example, here we can use some variables, or we can also use public variables, environment variables. Sorry. Okay. Me as a developer, if I fixed the problem, I can just put it that is fixed here. I comment as fixed and close this issue. Okay, I can close this issue. Wow. And see the other users. We have also a password user. Here we have a line that contain no secured communication. Here, okay, we have a communication without SSL. If we have a communication without SSL in our program of software, we can be sniffed by men in the model attacks. Okay, that's why it shows us that it's an issue. Okay, that's about the security issues. We have two about password protection and four about insecure communication. If I see the other issues in the security hotspots, here we can see that we have a weak cryptography issue. Here we are using a rand function in PHP, and the rand function in PHP is not safe. Okay, so how this function is not safe? This because if we have some numbers generated by this function, we can estimate the other numbers. Okay, well, I know that I just click on this, what's the risk? Okay, and he tell me that this function or this random generator function is not secured anymore. Okay, and how can I fix that? He telling me that I can use more or safer functions as random ENT or random bytes or open SSL random pseudo bytes rather than this simple basic random function. Okay, this is prioritized as high. Me as a developer, if I fix it, I can turn it to fix it. Okay. For the others, we have also the using of HTTP protocol that is not safe and vulnerable to attack to man-in-the-middle attacks. This is why we have a lot of HTTP protocol here, problems here. We have also some problems about resource integrity. Okay, this is resource integrity. Why it can be put as a vulnerability or an issue? Because at any time this external resource can be changed, and my code, if it depends on this external resource, and if it changes, my code may have some troubles in that part. Okay, voila. So this is what we got about security hotspots. And it's done. Okay, we have here also a weak hash algorithm is not used in sensitive context. The MD5 algorithm can be used easily decrypted using sites like Hashkiller. Okay, Hashkiller can decrypt not at 1,100% MD5 case, but it can enhash it. Okay, we have also MD5 decrypts. So the MD5 decrypt is MD5 algorithm is not secure at 100%. That's why we got here some issues or problems about this algorithm. Okay, at any time I can add developers to my solutions. Like if I have project that is developed by multiple developers, I can just come here and add the developers that can execute the analysis at any time, or admine the users at any time. Okay, so it's a complete platform of SaaS scans. We can scan here our products or our softwares locally, and we can scan them using the DevSecOps approach, using GitHub or other DevOps, or even for the olders, TFS. Okay, This is for the first workshop, and we discovered the SAST solution, which is named SonarCube. For the second workshop, we're gonna see the dust scan. Okay, here we scanned the source code, so we have the source code and we scan it. Now we're gonna see the opposite way, how we can scan a product or a software that we don't have its source code. Okay, so here in this approach, we're gonna use a dust scan, which means a dynamic application security testing. We can use this open source solution, which is OWASP-ZAP. Okay, here we just have to open it, and we can select a website randomly for a scan. I'm gonna just put e-commerce site Algérie مثلا. Okay, here we got some result. I just gonna pick the first result, for example, only. Okay, I copy the link, the main link of this solution, of this website, sorry. Here we have two approaches of scanning. We have the non-authenticated or public scan. We can scan the website without providing any credentials. Okay, me, for example, in this site, I don't have an account. Okay, so I'm gonna use the public scan. But if there is a website that is protected by a login page and I have a login or I have credentials in this website, I can also put the credentials to ZAP for more or for better quality scan. Okay, donc here I'm gonna put my link. Here I can tell OWASP-ZAP if I want to use a spider, which is our web scraping tool, or not. The web scraping will help us to identify the page that are not publicly visible but are present, for example, in the source code. Okay, so it's gonna make a web scraping to identify the maximal number of pages. Okay, if I take the web spider options, it can last a lot. Okay, so it can last a lot. So I'm gonna just put here never. Here I put the link, and now I can scan. Okay, as you see here, the solution scan automatically every public page in the website. Okay, all those pages are visited by our web solution dynamically. Okay, here if I go to alerts, I can see the alerts of vulnerabilities that are present in this website. I can see that is a problem about anti-CCRF protections that help us to protect the forms in our websites. We can see here that we have also a vulnerable JavaScript library. We can also see that there is not CSP header protections for cookies protections and sessions protections. We have also a medium vulnerabilities about anti-click jacking header. Okay, so we have some information disclosure here. What means information disclosure? That I can it means that my website can provide some information without need, like here in administrator page can be not shown to a sample users. Okay, can be just protected in LAN, and the sample users can't see it. Okay, so that's it for the dot scan. Okay, as I said before, I could use the scraping tool for a better quality. And if the website contain a login panel, I can also use an account for high quality results. And that's all for our presentation. I don't know if you have some questions about Radar SAS scan or the scan. Put them in the comments and I'm gonna respond to you without any problem. نعم يعطيكم الصحة. So I'm gonna let the speech to Mr. Iyad to close this presentation.
Yes, sorry. Thank you so much, Abdelhamid, for this insightful talk. It was a real pleasure having you with us today. And finally, a big thank you to everyone who took part in this event, speakers, audience, and everyone. Thank you for your time, and see you in the next edition of DevFest.
Thank you too. Thank you.